Hey, and welcome back to another Revit video. I'm really excited about this video because in this video we're going to look at materials, and not just the data and the graphics of the materials when it comes to hidden line view or floor plans or anything like that, but the appearance tab in materials, where you put all your maps and make really awesome looking materials. Materials really are my passion, and when it comes to Revit especially, I love Revit materials. Now that said, I will even venture as far to say that I abhor the way Revit sets up their materials and how you have to organize your maps and everything like that. But because I love materials and Revit so much, I have dealt with it, I've learned it, and I want to share my knowledge with you when it comes to making beautiful looking materials in Revit for all your renderings out of Revit, all your Enscape models, twin motion, whatever it might be, whatever you want to do. Make beautiful looking materials so you can always know that you're going to have great looking models with good materials. So let's get into it now. I will say, as I navigate to the materials, if at any point in this video you do happen to learn something, if you wouldn't happen to demolish that like button, it really helps me out so much. So I am in a base template Revit 2020, nothing special here, but there is a distinct difference between Revit 2020 and previous years. The previous year I used was 2018, but this was first seen in 2019 when we were first introduced to a different kind of material. And I'll go into that a little further into this video, but you'll notice I'm in Revit 2020, and you'll see that all these materials have these orange looking triangles here at the corner of all these material icons. And if we hover over this, we can see it says, for improved rendering, replace the current appearance asset in the material with a newer version. So what does that mean? Well, with Revit 2019 actually, and now still in 2020 and even 2021, we have what we see now as legacy material. So every material here that you see that has this little exclamation mark, it's almost like a warning in a sense. It's saying that this is a legacy material. Now it will work all the same in the sense that all the materials worked in 2018 and previous. It's going to work all the same. So you still have the option of using and building materials in the exact same way, but with Revit 2020, we have a more improved version, more improved way of building materials. Therefore, we get a better looking result. So let's go to the Appearance tab, and I'll start to show you some of the differences. So looking at it now, we can see that we've got all of our information, and we've got our generic, we've got our color, our image, and all this. We've got reflectivity, transparency, cutout, self-illumination, bump, and tint. Okay, so this warning is telling us that this is a legacy material asset, and the material asset is this acoustic tile exposed grid 2x2 pebble white, and it's in the Appearance tab only. And we can actually change this asset out. If we go up here to the top right, it says replace this asset. But before I do that, I want to actually just make a new material because we want to start from scratch here. So let's create a new material, and I'm just going to call this stone because we're going to be working with a stone today. So I've got this stone, and we can still see that I've got this unfortunate warning here that it's a legacy material. So I come into the Appearance tab, and it says just generic 10, and that's just what's going to happen. You're going to see that generic. You basically have to have a material asset or something filling out the information in the Appearance tab in every material. And if you don't have one set up already, like all these have these set up already, if you don't have one and you just create a new material, Revit will put a generic for you. And that's why you can see we have like 10 generic materials, which that's kind of annoying, but nonetheless, that is what happens. One thing I want to say now is that once we're working in the Appearance tab, we are now looking at specifically a material asset and not a material. I'm going to save that complete discussion and an in-depth guide of the differences between materials and material assets for a future video, but I just want you to know that the Appearance tab is a material asset, and the Identity and Graphics tabs are the material that we see here at the left. So getting back to what we were looking at, we want to change this from a legacy material asset to a new version, the latest version. So I can simply go to replace this asset. And if you remember before, we of course still see these warnings, but there are a few different materials here, and I'm just, of course I'm in nothing special of this out of the box physical assets. That's where you want to look. But anywhere you look and see that you have this warning is obviously the same older material, legacy material. But if we start to look at all these other ones, we can see, okay, there's no warning. This is actually a newer material out of Revit. And so what you're gonna have to do is pull one of these in. And so like I said, we're making a stone. So it doesn't matter what I pull in. I'm gonna have to deal with changing this and updating it later. But go ahead and replace the current asset in the editor with this asset. So again, we don't have that warning, so it's a new material. And we're gonna replace it there. I'm gonna close this, and now we can see our wood. That's exactly what we pulled in. But if you just take a quick look at everything here, it's slightly different. So we have information. We've got now parameters, translucency, emissivity, relief pattern, cutout, and then advanced highlight control. So this is clearly different than all of these. This is very different. These are all different. There's no bump in the new materials. So looking at this now, we have our new material, and this is what we want. But okay, like I said before, this is a stone. We don't want a wood. So what do we have to do? Well, we're going to have to duplicate this asset. It's like duplicating the type or anything like that. You don't want to just change this property, because if you change this, then it will change it everywhere you have this birch. So again, I'll save like the whole asset and material for another video, but for the sake of this video, we're going to have to duplicate this because we don't want to lose all this information we have for this birch material. So let's duplicate this, and as soon as I duplicate it, the only change you'll see is that I have birch and then parentheses 1, but we don't want that. We just want to call this stone. It doesn't matter what you call it, but let's call it stone. And of course, if you want to give it any kind of description, that's great. I tend to give it a brief description, but honestly, I care more about the keywords. So maybe I would call this stone, and I'd call this running if it's running bond, whatever type that it might be. If it's stacked, great. Just because this is how you're able to search for this material in the future. So at this point, you're thinking, all right, now we need to actually start adding the maps. Well, yes, we do. But before we do that, I want to take a moment and explain all the different types of maps that are now available to us with materials in Revit, starting in Revit 2019, but now especially in Revit 2020. What I'm looking at now is, of course, just this base image pattern. I can now see reflectance, roughness. I'm going to expand all of these. We've got translucency, emissivity, relief patterns. We've got a cutout option, and then all these advanced highlight controls. So there is a lot here. I'll expand this so we can see them all at once, but there is a lot going on with just this single material. And honestly, it's, in a way, it's overkill, but it's not. Unfortunately, just the way it is, it's not. So all this information is, in a sense, stacked together. All these different maps are stacked together to give you one better, like, beautiful looking material. So what are we looking at here, and what is this called? Well, all of this is called a PBR material, or a physically based rendered material. If you look up online anything physically based rendering, you'll quickly know that it is dealing with properties that are actually real, like real world properties. So it's taking all this information from the real world, or at least you have that option to, anyways. You have the option to do that, but more of what you'll see as far as physicality is dealing with light in a real way, and not just taking that one image and then pasting over and over again on your wall. It's not like SketchUp in a way where you're going to tile this image and it's going to look the same regardless. The idea with physically based rendered materials is that they will react differently to the light. You have your light set up in a scene a specific way. It might change over time. Maybe it's a video. Obviously, your light might change over the time. And throughout the course of the video, or a number of renderings, you want the materials to act like they would in the real world. Whereas if you look at a SketchUp model and you change the sun, that material is going to look static. It's going to look the exact same regardless of where the sun is, how much light is hitting it, anything. And that is the whole point of these physically based rendered materials, is that they can react to the light. They give you a more real looking material and actually have the ability to take properties from the real world and apply them to the material so you can get that real looking effect. So let's start from what all of these maps are. And it is a bit overwhelming, and it can be, but I want to break this down in a way to where it makes sense And to do that, I'm not just going to start replacing all of these materials and all these maps. I'm not going to do that. We're first going to jump to an explanation of all these different types of maps. So you have an idea of what they are, where they're used, how to use them, when to use them, anything like that. So this is the material that we're going to be working with today. It's just a basic limestone tile material. It's not all that special, but we're going to make it look good in Revit. And we're going to do that with all these different types of maps. So if you see all the, basically you want to be familiar with these types of maps when it comes to Revit 2019, 2020, because now we have the ability to use all these types of maps for our materials in Revit. And so like I said before, what these PBR materials are going to do is take every one of these maps and stack them up together and pull them together in a way to where all the properties and data built within these maps will give you a real world effect, real world material. So how does it do that? Well, each one of these maps is doing something completely different, and whenever you put them together, you get the desired result, actually. So let's look at that. We're going to start with base color, and you're going to see base color in a number of different ways. You might see it called base color. You might see it called diffuse, a diffuse map. You might see it called albedo map. You've probably heard of all those types of maps before. Maybe you knew what they are, maybe not, but regardless, it's just the base color. So the idea is that this map is defining the color and location of that color on your material. And that's it. It deals nothing with light, nothing with shade, nothing with shadow, nothing like that. Just the color. Like where do I have black? Where do I have white? Where do I have blue? Where do I have yellow? All of those types of things. It's taking that color data and putting it there. So moving on, the absolute biggest change when moving from a material in Revit 2018 to 2019 or 20 is that we now have the option of using normal maps. If you remember previously in that legacy material, we were only stuck with a bump map, and I'm sure a ton of you, and if not all of you, have heard of a bump map because it was basically what you can still use, but it was all the rave years ago, and it's really kind of where materials started as far as giving it height value. So the idea is now is we don't have a bump map. We don't have that value, that bump value, but instead we have a normal map. And so what is this normal map doing? It is, in a sense, taking the place of a bump map, but in a sense, it's actually higher detailed and it's more accurate, and you can actually take it much farther. Normal maps will appear to be mostly blue. They range basically from blue being the highest value to like these deep green, like teal and like lime greens, to some of these like pinks. Those are some of the deeper values. So and that just makes sense if we look at this tile. We've got the tile itself, which is this flat, it's a flat polished tile. So it's this flat blue, and then have all of these grout lines as recessed areas, and so there's actually height value there, and you can see that value change with the color. So you can start to see if I put this color on top of that normal map, where the normal map is starting to apply a push and a pull in the height, then we're going to start to see some dimension in the z-axis. So then you might be wondering what the height is. Well, before we, like I said, we're stuck with a bump map. And so you could kind of say that, in a sense, the bump map is both the normal map and the height map, but it's not quite that. With the height map now, this height map is going to take the data that you have from this normal map and actually apply it to 3D. It's going to make it 3D. It's going to apply tessellation to this material and basically give you a series of triangles that create the material. Of course, you'll never see those, but the idea is that this height map is actually able to take this normal map and make it 3D by creating a quote model of it by tessellating it, adding triangles everywhere. And if you've seen like some chopped up SketchUp models, in 3D, they basically are tessellated. They've got all these different triangle squares that create this 3D form. So in a sense, that's what the height map is doing, to give you the actual 3D definition of a normal map. And so in Revit, from the best thing I can tell is that we actually have the option of using a normal map or a height map. You can choose either. So in a sense, at least from what I've been able to tell, is that you have the option of using both, but you're going to get basically the same result with either. Now, I happen to, my opinion at least, is that the normal maps are stronger, they're more effective, and you can do a lot more with them, so I would recommend using normal maps. So we'll get into that soon. Finally, moving on to roughness. It is pretty self-explanatory. It's basically determining how rough a material is, and I know that makes perfect sense because that's what it's called. It's a roughness map. So you'll see roughness maps are grayscale. They are white, black, anywhere in between. And so the idea is that everywhere you see black, it's completely smooth. It's polished and everything. It's shiny, reflective, everything. It's not rough. There's zero roughness. And wherever you see white value, like completely white, that is 100% rough. So you can think from black to white, 100% rough is white. So this makes sense, again, if we compare this roughness map to our base color map. Every tile itself is actually polished, and so we can clearly see that black is, it's basically 100% polished, so it's reflective and everything. And then we've got some of these grout lines, which are, some middle gray value, tending to be more towards white than black. So they're more rough, and so that makes perfect sense because grout is not shiny, smooth, and everything. It's pretty rough looking. So that makes perfect sense. But now moving on to metallic. This can be confused with roughness sometimes, but it's basically determining how metal a material is. And again, metallic maps operate in the same way roughness maps do, in that black is 0% metal and white is 100% metal. And so the idea here is that my stone tile here is, in this case, 0% metal. And that makes perfect sense because it is a stone tile. There's no metal. Now, if you happen to have, pieces of metal spread throughout, you would start to see those populate throughout the map here at various different white values. And they would show up differently than any other value that is not metal. Basically, those spots on the material would begin to show up more metallic looking when it comes to light and everything than other parts of the material. And so finally, ambient occlusion. This is probably one of the most powerful maps when it comes to affecting the light, because this is basically telling the material how to react to light. That's really what it is. What happens when light hits the material? And that's going to be determined by this ambient occlusion. Again, we are looking at a scale from black to white, and black being that light is not really affecting this area. And so if we start to look at some of the grout lines, it makes sense that with a more rough grout line, obviously here we can see in the roughness, the grout lines are rough. We could determine that, back to the ambient occlusion map, that these darker areas are going to be less affected by light, and therefore there will be less reflections and everything like that. Light is less affected. Whereas if we look at these solid, flat, smooth stone surfaces, light's going to be greatly affected by this area. And that is just because it is a smooth and polished looking stone tile that light can bounce off and do whatever it wants. And that just makes perfect sense. So I know this was kind of confusing, and if you haven't seen or heard of this before, I'm sorry, but this is a lot of information, and it will be really helpful for you to know when it comes to building amazing looking materials in Revit 2019, because we have this capability now to input these types of materials into Revit, into our Revit models, and make them look awesome. And in a future video, I'll do a comparison between a legacy material in Revit and then a new physically based version within Revit 2020. So I want to share this with you now, and I'm just online. I'll have a link for this in the description below, but this is a table that I regularly reference from Dontnod Entertainment. It's just looking at different values and to help you get an idea more visually where to put your data and put your numbers and values when it comes to building these physical materials. And so at the top, we can see base color sRGB, and obviously this makes sense. It goes from black to white. There's nothing special there. Of course, you can add all the colors you want here. But this section here, it's all about luminosity. Now, You will not find this option within Revit, but if you're building materials in a lot of other 3D programs, you might have the option to input a luminosity value for your material. And so what is this? And I'm going to only talk about this very quickly because it doesn't necessarily apply to Revit, but it applies to physically based materials. So the idea is that you can copy this color and use it as that luminosity material. And this color is directly related to the color and interaction of the light on the material. So if we take, iron, for instance, iron is a color, but the way that the light interacts with that material, it would be different if I chose a luminosity color of red. It just wouldn't make sense because the light would appear to be more red coming off of that material. So this makes sense because the iron is close to this color. It makes sense. So the idea is that you copy this color, and if you're making an iron, you apply that color to the luminosity so that the light that is created and bouncing off and like coming from that material is that color based on the luminosity. So again, you won't necessarily see that in Revit, but I just want to share that with you because it does apply to physically based materials. So this is starting to get into some of the more visual, helpful aspects of what I just covered when it comes to these material maps. So looking at metallic, again, so black is 0. There's no metal. It's not metal at all. And we can see here, this is, while there's still some like shininess and polish to it, it's not technically metal at all. Whereas if we get all the way up to 1, a value of 1, we can see this is clearly, it's a metal, it's polished, it's very clear that this is a metal value, and it's a metal material. And you can see how the different values give you a different result, different reflections, different everything. And so if you have an idea of what you're looking for in a material you're building, you can use this to determine the level of metalness that you might want. Moving on now to roughness. We're going to look at the exact same thing. And again, the roughness value from 0, it's black. 1, it's white. If we take a roughness of 0, it's basically going to be, metallic looking. It's going to be more polished. So if I choose metallic and it's 0 as in no roughness, it's very polished. You can clearly see that there. But if I have a metal that is very rough, then you're still going to get some of these reflections and it's just going to be more opaque looking. You're not going to get quite the polished look. Whereas if you have this non-metal value, you're going to start to get this darker looking flat look if you have this 100% rough with it, and it not being a metal, and it just makes sense. And we can see some real world examples from images up here. So we've got this basically 100% reflective metal ball here, and that just makes sense. It's basically a mirror. When you put a roughness at 0 at a metallic, it's basically a mirror. And we can start to see some of these things change. But finally, when we get to this coin is clearly it's metallic, but it's basically like 100% rough. So there's really no reflections, really no polish to it, and that just makes sense. And then finally, you're not going to see this value in Revit, and honestly, I've never really dealt with this, but nonetheless, on the chart is porosity. It's just another map that you could apply. And in some highly advanced material programs, you might see this, but it just makes sense again. Again, we're going from black to white, black being 0, white being 1, 100%. We're taking this like granite in the lower values where, water will not penetrate granite like it would a clay pot or sand or something like that. It just makes sense. So I'll leave you a link to this in the description below so you can reference this as needed. So let's get back to Revit. So with all of that knowledge, I know that's quite a lot, and I sure hope you learned something from all of that. We're going to actually start building our material now. And I'm going to show everything when it comes to building it and tell you what I'm doing and why so that we can build an effective material and take a look at it in 3D. So here we go. We're going to take our image, and this is a little misleading, but parameters. This doesn't tell me anything, but basically under the parameters in the image is going to be your base color, your diffuse, your albedo. This is determining your color. And we're going to do that by changing this from a different image. We're going to change the image out. And you actually have the option of choosing a base color if your material is like 100% a green, great, you can do that. And I want to cover this now because you could have this color be green and be done with it. It could be green. And if you remember in the last video, and I highly recommend you check it out, if you look at the graphics tab and you under the shading, you check use render appearance, you're going to start to see that green pop up in all your views. So just be aware of that. Now, if you check this box and you have an image applied, it won't matter. Nothing will happen. It's all about the image. So in this case, we don't want the color. We want an image. So it's now going to prompt me to add an actual image. So if we look at all of our materials here, I've got all my different material maps. We've got our base color. So I want to start with this base color. And the big thing at this point now is to actually get the scale correct. So as I click on, I now, once I have it loaded, you can see it's right there. I can click on the image itself and I get this texture editor window that pops up. And this is great. And you're going to start to see all these different properties in here. And again, there's a lot here to look at, but most of these things we're not going to have to tweak, thankfully. So some of the options we have is the brightness. Now, I have gone to the immense trouble of making this material look beautiful already. I've built it in a way to where I know everything looks good. So I don't want to change the brightness of this material. I can't see a world where you would want to if you've gone to the trouble of making the material look good. You want it 100% brightness. It just is what it is. Of course, you can invert it if you want to invert it later on. I would probably invert it later on if I wanted to make my beautiful looking black marble a white marble or something like that. But regardless, we don't want to invert. A lot of times I will go ahead and check this link transforms, this link texture transforms. It says when this setting is enabled, all changes made to the position, scale, repeat settings of this attribute will be propagated to all other attributes within the material that use a texture. So perfect. This is basically saying that once I check this, it will link the texture transforms between all the different texture maps I put in here. And I want to do that because maybe I need to change the scale later on. Maybe I want to rotate it or something, whatever it might be. And I don't want to have to do that to 5 different maps. That makes no sense to have to do that. So link transforms. You're going to have to check that for all of them, unfortunately. But as we go through that and build the material, make sure you do that. So the position next, offset, rotation. Again, I built this material in a way to where there is no real need to like add an offset, do anything like that. Obviously you can if you want, but I don't need to. I don't need to worry about that. Then sample size. So basically, you're going to have a map, and hopefully it's seamless. And I might cover in a future video how to make seamless materials, but I'm assuming that you have a seamless material. And honestly, even for this position and sample size and everything, that whether it's seamless or not doesn't necessarily matter, but getting the scale right really does matter. I happen to know that these tiles are 1 foot by 4 foot, and that the size of this material is actually 30 feet by 30 feet. So I'll just put in 30 feet there, and assuming you have this still locking the aspect ratio of 1:1, it's going to change both of them for you to be 30 feet and 30 feet. Obviously, if you want if you have a non-square material, maybe you have a double 30 by 60, you can do it just like that, and you'll see it populate like that. Now, I don't have that. I have a square, and I would generally recommend using square because it will just be easier to work with, but obviously there are some instances where you can't. And finally, repeat. Horizontal, you can actually have different repeating options when it comes to horizontally or vertically. So we have the option of tiled or none, or tiled or none. So because I've gone to the trouble again of making this a nice seamless looking material, I want this to tile when it comes to horizontal and vertically. So that's it. I've done everything I need to do for the base color. Perfect. Okay, and so finally, we're moving on now to reflectance. And this, unfortunately, is not necessarily a value that you would probably see in a form of a map. It's more of something that you're inputting yourself. And this is going to come with experience, but I don't have a great way of giving you an idea of where this value should be. But the value in Revit goes from 0, and it goes by 0.01, 0.02, all the way up to 0.08. Being basically 100% reflective. Now, I would probably say that this material is a solid 0.05, a little over half. So that's fine, and I'm not going to worry about that so much because it's not going to have a gigantic impact. So moving on now to roughness. This is very clear. It's obvious and it makes sense because we have a roughness map. It just makes sense. So I'm going to not only just edit my image, but I can click on the link here, but I can actually change that to my actual roughness map. So there's my roughness map, and I'll click open. Now again, I want to click this material and make sure I link texture transforms, and we can actually already see that the 30 feet has already been populated, which is perfect. That makes our life so much easier. We can click done. Now we're done with all the parameters here. I'll close this for now. Translucency. Not a lot of times do I deal with this. Obviously, check this box if you have a translucent material. If you do have a translucent material, if you're making some sort of glass, then that's where you can start to input some of these values. Now, I will say that this is not necessarily a map either, and while you can make it an image, I have really never gone to the trouble of doing that, and I don't think it's quite necessary. Obviously, you can give this a different depth value. It's just basically the depth of that transparency, the depth of that glass, whatever it might be in that material. But we don't want to deal with that in this case, and 99% of the time you won't need to unless you're making a specific glass. So I will close the translucency. Emissivity, I love emissivity, emissive materials. I think everyone does. And if you don't know what it is, emissive is essentially self-illuminating. So previously, I believe it was called self-illumination, but regardless, it's called emissivity now because it's actually emissive, like that's an actual property. If a material is emissive, it is producing light itself. So if a good example of that might be an actual light bulb. Because the light bulb itself, while the surface of the light bulb may not necessarily be producing the light, it's actually the filament inside, whatever. For the purposes of rendering and Revit and all that, you would probably add that material, an emissive material, to an actual light bulb until that light bulb glows and produces its own light. So again, I'm making a stone. I don't necessarily want to do that. It's pretty self-explanatory. Simply check that box, filter color, pick an actual color that you want that light to be, and then determine how bright it is. And you can start to see even in the preview up here how ridiculous this gets and how quick. So I don't want that emissive value there at all. I'll expand this so we can see the image a bit more. Looking now at relief pattern. This is probably the most exciting and I would say the biggest advance in Revit 2019, Revit 2020, the fact that we can now have different types of relief maps. So I'm going to click on this and I'm going to change this to my normal map. And I'm going to do this here. I've got my normal, my limestone polished normal. And I'm going to change it there and you can see it shows up as blue. But the thing to be aware of is that if I click this here, go into the properties of this texture editor, I'm going to make sure to link transforms, of course. But there's a few extra things to look at. And this is the exciting part. So of course we've got the position with the offset, the rotation. Don't need to change those. We've got the scale, that's great, but now we have a depth. This is awesome. You can put really any value you want here. You can take it as crazy as you want. I haven't experimented hundreds of feet or multiples of feet because that's really not necessary in all these materials, and I can't say that Revit would do a good job of pushing those materials that far. So if I look at this, if I want to change the depth, unfortunately, the way the depth works, it looks like I can only take this as far as 3/8 of an inch. Now, maybe that's a limitation within Revit. Maybe that's a limitation within this material. I think it's more likely to be Revit because I haven't had this luck anywhere else. But definitely, if you have been able to get this value higher than 3/8, so like if I put in 1 foot, I get -3/8. Okay, that makes sense. If I put in -1, I get 0 still. So regardless, it would be nice to be able to put more than 3/8 into this. But if you're able to find that out, why I can't do that, or if there's a way I can, please leave those in the comment section below. I'm really curious if you can discover that. Finally, again, we see this repeat. It's on tile. Of course, I want it on tile. But finally, advanced. Here's my data type. I've got my height map or my normal map. So this is a normal map. And of course, as soon as I change that, I now have this depth amount. And this depth amount has changed. And it's changed from a value of, like a physical value. When I had this height map here, there's a depth here that maxed out at 3/8 of an inch, which is really too bad. To now, if I change this to a normal map, it's kind of giving me some numbers. And it looks like the numbers go from 0 to 5. And so I will tell you now that 1 is going to be basically what you built in the material. The default height you gave to that material in however you build the material, whatever program, whatever it might be, the depth is 1. Basically, that's just what you need to know, because I can then start to double this, triple this, take it up to 5 if I want to max it out, but at least there's a range. And to me, there's a larger range with the normal maps compared to the height maps with just this basic 3/8 dimension. I prefer normal maps not just because of the depth, but the fact that I feel like I have more control with the depth, but this, the quality of the normal maps, I've received much better looking materials that way. So that's it for these normal maps, relief patterns. I'm going to hit done, and we can really start to see we're starting to get some more depth out of here. So Cutout is very powerful, and I think highly underrated and underutilized in Revit. It's basically like if you need to make a chain link fence, you can actually make a chain link fence with all these metal values and everything, while also cutting out the center part of each one of the chain links, so to make it look like a fence and actually see through it in Revit. So again, this is a stone material. I don't want to do that. I don't necessarily need to do that. I might save that for a separate video because that's a specific material. But it would be pretty self-explanatory, because all I would need to do is add a cutout map. It's just a different image map, a black and white image map. Again, it's very easy, a different kind of black and white image map to cut out. And so a good example of that, I guess in the case of stone, maybe I'm making a more rough looking brick or stone wall. I could actually take my, probably my roughness map, and I'll go back to that so we could just see it. My roughness map here, I could take that and make some of these random stones be white. And if I make them white, they'll be removed or like taken out to where the point where you could see through the material. And so that stone wouldn't be there or exist at all. So that's how you would use that cutout. And it's pretty simple. You can edit that yourself in Photoshop very easily. So finally, I would say the most advanced portion of this material, and so we've got a couple more maps that we have yet to use. And that is primarily of course, the metalness map, the ambient occlusion being the most important one when it comes to light. So where are we going to start to use that? So we've got this. These are just looking at these values and what they're called is kind of confusing, but we're going to go into it. So if we look at this first value, it's anisotropy. Okay, that's great. So let's see what it is. It says controls the shape of the highlights on the surface by making them elliptical rather than circular, used together with roughness. So long story short, a lot of times what I'll do with this anisotropy is I'm going to change this to my ambient occlusion, because this is actually going to take in the light and determine how the light is viewed in your material, and that's all based on the light. So I want to change this to an image, and I'm now going to go to my ambient occlusion. So there's my ambient occlusion. I'm going to go ahead and link texture transforms once again. And now I'm going to make sure that's set to 30 feet. And because I didn't have an image map here, it wasn't able to link that in. Make sure your offsets are the same throughout. That's perfect. We'll hit done. Okay. And so orientation is, the example they give here is it's used with a texture map. You can recreate woven materials where the direction of the highlights are perpendicular to each other. So the idea is that the light it's hitting in a way perpendicularly to give the woven look a deeper effect, deeper look, an actual deeper 3D effect. And because this is a stone, we don't necessarily need to do that. But honestly, I've never gone to the trouble of using this orientation, mainly because I'm not making some detailed woven material or anything like that. It's just the way it is. I'm not necessarily needing to do that. But a lot of times what I'll do is I'll put this ambient occlusion in this anisotropy, because it just actually takes those light values that you have in Revit and Inkscape or wherever and start to apply those to material in a much better way. And I don't even mess with the orientation, because I don't want that. I don't want anything further adjusting what the values are of this ambient occlusion map. I don't need to do that. There's no real worry of doing that. And of course the color, this is kind of getting into that luminosity, but Honestly, it's not. It's a little different. It's more or less the light that is resulting from the material, what that color would be. And you can even see it here. If I read this in Revit, it's going to tell you kind of where you should land. It says determined in color or the weight of the specular highlights on the material. Generally, this parameter should be set to white for physical correctness, and that makes perfect sense. You know, white, light, the sun is white, all that makes perfect sense. But of course, you can change this value for artistic purposes, it says. Now, I've never actually changed this value from white, never had any problems. I wouldn't recommend changing this from white unless you have some sort of artistic reason. And finally, shape fall off. This is kind of interesting. It determines the underlying equation used to calculate reflections and highlights on the material. The long fall off will produce highlights that appear smoother, while the short fall off will produce highlights that appear sharper. So it's really your preference. Now, I will say the number of times I've changed this from short to long and tried to see the difference is probably hundreds, but I can't really tell the difference. Now, maybe it's just the type of material I've built or the scene or whatever it might be. So use that wherever you want. So in this case, because it's kind of a low, tight-looking material, it's on the ground, I probably want a short fall off. Just real crisp, solid shadow lines, very minimal shadow lines, of course, anyways, if this is on the ground. So we have built our material. You will notice with all of this built and all these parameters filled out, we've got a nice looking material. I know it looks a little big, but we haven't used our metal map. And, unfortunately, there's just no place to put that in Revit. There are a number of places that you could arguably place it, and that might be in reflectance. So I've experimented with that because reflectance expresses how much light is reflected from the surface in like a mirror fashion, specular reflectance, when looking at the surface perpendicularly. Note that this material will always show a high specular reflectance when looked at grazing angles or Fresnel's effect. So yeah, you could debatably put the metallic map here, and I'm going to go ahead and do that, but the idea is that if I have a metal map, and again, I'm going to make sure my link transforms are here. I've got my 30 feet by 30 feet because I want things consistent, tiled correctly and everything. So you can do that all day, but the reason I didn't necessarily do it for this material is that it's 100% black, which means it's not affecting it at all. Now, you also might say if I had a slider and I had the value at 0.05 or something, that might be a bit different, whereas I should have actually had my reflectance at 0. But nonetheless, that's particularly why I like to probably just keep my reflectance value an actual value and not deal with having a different map because, like I said, there is no metalness, and so it's different than the reflectance because there's no metalness to it, but there's reflectance. So that's why I would not necessarily use the metal map here, whereas in some cases you could, or there might be a good advantage if you want to get specific with where you want the reflectance to be. And again, that's just going to be where the white values are. So we've gone to this trouble. We've made all of these material maps, and we placed them all correctly. They're at the right scale, everything should look good. So let's go ahead now and place this into our Revit model. So I'll hit OK. And I'm going to make a floor. Go to architecture and floor. Let's go ahead and make a giant floor here. That works. I'll hit OK. And let's change the material of that floor to our stone material. So there's my stone. I'll hit OK. There it is. Right there. And of course, I have not gone to the trouble of making any types of hatch patterns for this. You can find that in the separate video that I've done for the graphics tab in the materials dialog box. Now we just need to look at it in realistic because realistic views are directly related to and pulling from the appearance tab. So if I look at realistic, we can zoom in here and really see all of this material, and it looks honestly blurry and pretty terrible. And the reason for that is it's just Revit. It's just kind of the way it is. And I honestly, it's just me personally, I don't build materials to look beautiful within Revit itself. I build materials to look beautiful in external programs. And so the idea now is that I'm going to start Inkscape, and we're going to take a good look at this material in Inkscape to get an idea of what to expect from a high quality material that is in a really good looking render engine such as Inkscape. So let's start up Inkscape. So here we are in Inkscape, and here's my stone floor. And we're going to zoom in here and take a look at it and really get an idea of what this looks like in Inkscape. And honestly, this looks pretty good. And we can even start to see some of our reflectance values coming in. We can see the reflectance off of those clouds up there. It's really looking pretty good. See, there's my reflectance working really well. I've got a nice polish to this. And even if we zoom in here, we can really start to see, yeah, it does, the quality loses a bit as we get in here, but really you can start to see some of the depth that's coming in to some of these nice places. And it really does look like specific tiles along the path here. And even as I move the sun, you can clearly see all of my reflectance and reflectivity updating. And like this looks, it's really good, and the quality is really good because, you know, just having the ability to use these physically based materials in Revit is just a game changer. And I will make a separate video again when I compare everything from Revit 2018 to 2019 and 20, looking at, you know, legacy materials versus all these new PBR style materials. We're going to see the difference heavily in Inkscape, especially these external programs. You're going to see it. And honestly, I wouldn't necessarily bother, me personally anyway, I would not bother building materials for Revit and rendering out of Revit. Of course, they will look better even with these physically based rendered materials. But the fact is, all these different programs make them look just so good. And just, it takes no time. The fact that this looks so great, and like this tile, this limestone looks great. So that will do it for this video. We covered everything that has to do with the materials appearance tab in Revit, all the materials that you need to know. I love materials in Revit. I wish things were built a little differently, but hey, we got to work with it. We're kind of stuck with it for now. I'm sure it'll be a little while before we get any kind of updates with materials, but nonetheless, we have physically based materials now. We have the option of adding all these different properties and maps. So I sure hope you learned something. And if you did, please demolish that like button. It really helps me out so much. Also, please change the phase of that subscribe button to existing. That also helps me out so much. I can't thank you all enough who have. And if you stuck around this long to the video, you're awesome. You're really awesome. I really appreciate it. I sure hope to see you in the next Revit video. Have a wonderful day, and thanks for watching.